Good evening students, welcome to basic electrical lectures. So we are doing lectures on module 4 second part, that is DC motors. So it is class number 11. I request all my subscribers and viewers watch the video lectures in a proper sequence. So in this lecture we are going to learn different types of DC motors and its voltage and current relations. What is important is voltage and current relations on all types of motors. That is very much important. Okay, we are using this while solving problems on DC motors. Okay, so to solve problems on DC motors, you must know this topic, voltage and current relations. And this and all is very simple to classify the types of motors. So what we learned, the classification of generators or types of DC generators, in the same way DC motors also classified. So DC motors are classified into three types. One is called permanent magnet DC motor. So it is like this: armature is connected to the supply and these two are permanent magnet. It is having a certain flux. So this flux, okay, whenever current flows through the armature conductors, it is going to produce conductor flux, magnetic field around the current carrying conductors. That magnetic flux going to cut this main flux produced by this permanent magnet, and this permanent magnet is fitted in the stator inner periphery. Okay, so outside stator will be there. In the stator inner periphery, this permanent magnet is fixed. So there will be some lines of flux. The conductor flux cut this main flux, and hence EMF will force is exerted. Due to that force, the armature conductors will going to rotate. The armature rotates. Like that, the motoring action takes place. Okay. And next is separately excited DC motor. So here, the field windings of DC motors is given to the separate source, and armature is also given to external source. Okay. So the only the distinguishing fact in a separately excited DC motor is the armature current does not flows through the field winding. The current flowing in the armature will not flow through the field winding. Okay. Next, important is this one. So self-excited DC motor. So this is very much important. Sorry, red is not working. So it's not writing. So let me write once again. Okay, this is important. Okay, separately excited DC motor is very much important. So black also not working. See, self-excited DC motors are nothing but the field windings are connected either in series with the armature winding, then it is called series motor, or in parallel with the armature winding, then it is called shunt motor. Partly in series with the armature winding and partly in parallel with the armature winding. If I connect the field winding like that, then it becomes compound motor. Compound motor will have both windings, shunt field winding and series field windings. And based on the arrangement of shunt and series field winding, the compound motors are classified into two types. One is long shunt DC compound motor, and another one is short shunt DC compound motor. So further, in long shunt and short shunt, further we have two types, that is cumulative compound motor and differential compound motor. Similarly, for short shunt also cumulative and differential, okay, are there. Then what is cumulative? Cumulative is nothing but the shunt field winding will going to produce shunt field flux, and series field winding will produce series field flux. The shunt field flux and series field flux are helping each other. If both the fluxes are helping each other, then it is called a cumulative compound motor. If both the fluxes are opposite each other, the shunt field flux and series field flux, if they oppose each other, then it is called differential compound motor. Okay, got it? So this about types of DC motors. You just write this chart, that is sufficient. Okay, so to solve problems on types of motors, so next we are moving second topic. This is very much important, voltage and current relation. So it's very easy. Once you understand this theory topic correctly, you can easily solve problems within a smaller time. Okay, it won't take much time. So it is a time required to remember the voltage and current relation of certain type of motor. So they will ask problems on DC motors only on this self-excited DC motors. For this self-excited DC motors, only on that topic they will ask problems. Okay, got it? So we can concentrate this topic in detail. So I am going to write voltage and current relation for all this type of motors. Okay guys. So please copy down. Pause the video and then copy down what I written on this board. So shall I erase? Okay, now we can learn the voltage and current relation for DC shunt motor. It is one of the type in self-excited DC motors. So how it looks, let me draw the diagram. So this is the armature. So this will be the armature, and armature is directly connected to the supply voltage. So directly connected to the supply voltage, let me say DC voltage. So this V is nothing but supply voltage. This V is supply voltage. Okay. So this inside the armature, conductors will be there. That armature conductors will have some resistance. That armature resistance written as RA. So we know that motor will going to develop what? Back EMF. Motor will going to generate back EMF, EB. So now I want to connect the field winding. So if I connect the field winding across the armature in parallel with the armature, then it is called DC shunt motor. Then it is called DC shunt motor. So this is shunt field winding. So shunt field winding is having some resistance RSH. So RSH means shunt field winding resistance. Now we should mark the currents. Okay. See, this entire thing is motor. What motor is required? Motor requires what? Electrical input. What is the output of the motor? Mechanical. Okay. So this entire motor is connected to this supply. Once it connect to the supply, this motor will going to receive current from the supply voltage. So therefore, we can write motor receives current IL. See here, IL is nothing but a line current or supply current. IL is nothing but a line current or supply current. So, but in generator, IL is nothing but load current. Got it? In motor, IL is called line current. Make clarity in that notations. So now this current will come till here. Okay, till here the IL current will flows. After that, the armature resistance and shunt field resistance, how they are connected? Series or parallel? Yes, what you said, it is correct. These two are connected in parallel. So the current flowing in the armature winding is IA, and current flowing to the shunt field winding is ISH. So current flowing to the field winding is, here field winding is shunt, so notation is SH, suffix SH. So RSH is shunt field resistance and ISH is shunt field current. So now current relation, very important, current relation. So current relation means apply KCL. Voltage relation means apply KVL. That's it. Okay. So now this is a node. What KCL states? Can anyone tell answer? What KCL states? Yes, what you said, it is correct. The current entering to the node should be equal to sum of current leaving from the node. So what are the currents entering to the node? Okay, IL is entering is equal to entering current is equal to outgoing current. What are the currents outgoing from that point? IA is outgoing, ISH is outgoing. So IA plus ISH. This is the current relation for shunt motor. But in order to find the back EMF or the supply voltage, I need a armature current equation. So from this, I can write IA can be written as IL minus ISH. I am retaining IA here itself. ISH taking left hand side. Then your armature current equation will be IL plus ISH. Now, what is the equation for ISH? Equation for ISH. See, RA and RSH are connected in parallel. Okay. So, and this entire combination connected across supply voltage. So, in parallel voltage will be same. So, this voltage divided by this resistance, voltage by this resistance, you will get shunt field current. So, VT divided by RSH. So, not VT, V only. Okay, supply voltage V. V divided by RSH will give what? Shunt field current. But don't write for IA. V divided by RA is not IA. Okay, why means, see, inside the machine back EMF is there. So this back EMF opposes this voltage. So this voltage minus this voltage divided by RA, that gives value of IA. Got it? Don't make that mistake. Okay. Don't write V by RA is IA. That is wrong. Okay. Because inside the armature back EMF is produced. Okay. This voltage opposes this voltage according to Lenz's law. V minus EB divided by RA is equation for IA. Okay, got it? Fine. So this all relation you must remember while solving problems on shunt motor. Let me see the voltage relation. See, while writing voltage relation, you must replace the motor. You must replace the motor by its equivalent circuit. So what is having in the motor? Armature resistance. Okay, red is responding. Okay, armature resistance. And motor will going to develop what? Back EMF. So back EMF is this one. So plus minus EB. So I am just represented the construction, okay, the machine symbol by its equivalent circuit. Rest whatever is there, you write that everything as it is. Okay. So what we have later, we have field winding. Okay, it is having some resistance RSH, and this motor is connected to where? Supply voltage. So motor is connected to supply voltage. See, now it formed two loop. See, whenever I connected this to the supply voltage, so this will make one loop and this will make one loop. Okay. So don't apply KVL to these two loops. So later you will get two simultaneous equation, and rearranging that, in the end you will get one exact voltage relation. But that is time consuming. So while writing voltage relation, don't consider shunt field winding. Okay, in any type of motor. Okay, don't consider shunt field winding. Why means, the effect of shunt field current. See, when motor is connected to supply voltage, it receives current IL. That current will going to flow in field winding also. So shunt field current, and some current flows in the armature. Some current flows in the armature. See, whenever current enters the resistor, mark plus leaves negative. So you are requested to apply KVL only for outer loop. See, why I taken this direction? Because motor is receiving the supply. If motor receives supply, so this will be the direction. If for generator going to delivers current, that's why for generator I have taken clockwise. For motor you should take anti-clockwise. That's it. Okay. Apply KVL to the outer loop. Don't consider shunt field winding. Why means, the effect of ISH is already in the current relation. See, IA is equal to what? IL minus ISH. So therefore, apply KVL only for outer loop. So minus to plus is rise V, and plus to minus drop minus IA RA, and plus to minus drop, that is we have EMF source here, minus EV is equal to 0. What is this? KVL equation. In any closed circuit, the algebraic sum of all the EMF sources and individual potential drop taken with proper sign convention would add up to 0. First model. Okay, now you take all this negative to the right hand side. So V is equal to EB plus IARA. So this is the voltage relation for DC shunt motor. Okay, got it? So plus you can write V brush drop. Okay, because these are the brushes, it going to receive current. That current into brush is having some amount of resistance. So their brush contact drop will takes place, and that value will be very lesser. So in the question, if they specify, then only consider V brush drop. If they not consider, they not given in the question, then you take this brush drop is equal to 0. That's it. So this is the voltage equation of DC which motor? Yes, shunt motor. Okay, got it. So what is IA here? IA you should substitute here. What is the value of IA? IL minus ISH. How ISH is calculated? By this equation, V by RSH. These things, if you know once, you will get full marks in types of DC motors. Like this, for all types of motors, I will be explaining. Okay. So don't forward. Watch only one time correctly. Okay. Later the same video, even though video is lengthy, later once you understand, you can watch the same 1 hour video in 10 minutes. Okay. If you don't know anything, you watch the lecture without forwarding. Okay. That is my sincere request. So this is the voltage relation. Next is power input. So this is common for all types of motors. What is power input? V into IL. So input power, supply voltage into line current. So the product of this two will give us what? Power input to the motor. Okay. And power output. What is power output? Output power, where power is developed in the armature. Okay. So this is the input power, and power is developed in the armature. Power output or power developed. So power output is given as EB into EB, back EMF, into armature current. EB into IA. So it is also called gross mechanical power developed. It is also called gross mechanical power developed. Gross mechanical power developed. Where this power is going to develop? In the armature. So this power is going to develop in the armature. See guys, for all types of motors, these two are same. Okay, input power is VIL and output power is EVIA. Okay, got it? Okay guys, pause the video and then copy down. So next we are going to for series motor. Okay dear students, next one is DC series motor. See now armature is connected to the supply, but field winding. Now if I connect the field winding in series with this armature, then it is called series motor. So I am taking the field winding, I am writing in the green color. Okay guys, so this is a series field winding. See, same one field winding will be there. If I connect the field winding across the armature, it becomes shunt motor. If I connect the same field winding in series with the armature, it becomes series motor. So simple. So series field winding. So series field winding. See, this I not erased because I said no. it is same for all types of motors. Power input and power output, both are same for all types of motors. See now, series field winding is having some resistance RSE. See what I written there means RSE. Okay, suffix SE means series field winding. Okay. See now, what is the current? See now, this motor is connected to the supply. What it happens? It going to receive the current. Okay. Once this entire motor, armature and series field winding is connected to supply, it becomes closed circuit across some voltage. This voltage source will drive the current, but that current is received by the motor. So that current is what? IL. What is IL? Load current or line current? Very good, line current. Now whatever the current coming from the supply source, the same current is flowing where? In the series field winding. So therefore I can write the current flowing in the series field winding is ISE. Okay, ISE, not information science and engineering, series field current. Okay, so series field current, and whatever the current flowing in the series field, same current is flowing through the armature also. So the current flowing in the armature is IA. Okay, now you can tell the current relation. What I can write current relation? See guys here, series field winding and armature resistance. How they are connected? Series. In series, what is the concept? Current is same or voltage is same? Very good. Yes, current is same. So in series, current is same. Therefore, whatever the current coming from the mains or supply, same current flowing through the series field winding and also same current flowing through the armature winding. But the notations are different. Okay. IL, ISC, IA. All values are same only, but represented in different notations. IL is line current, series field current, armature current, but all are equal. So this is equal as per concept of series circuit. Okay, IA is equal to ISC and ISC is equal to IA. All these currents are having same value, but notations are different. Okay, got it? This is the only current relation for series motor. Next is voltage relation. See, while writing voltage relation, replace the motor by its electrical circuit or equivalent circuit. See, motor is having armature resistance RA and motor will going to develop back EMF due to this voltage is generated due to generating action in a motor. Okay. So now the series field winding and it is connected to the supply voltage. Okay, now what is the current from the lines, from the mains? The current is IL. Same current is flowing in the series field winding. Series field winding resistance is RSC and same current flowing in the armature. So I am writing with another notation, that is IA. Okay. So now it is formed only one loop. Only one loop it is having. So apply KVL to this loop. Apply KVL to this loop. Okay. So minus to plus is rise. Before that, mark the sign convention. Correct enters, mark plus, leaves negative. Entering plus, leaves negative. So minus to plus is rise. V, plus to minus, drop, minus, what is that drop? ISC, RSA. Plus to minus, drop, minus IA, RA. Plus to minus, drop, minus EV is equal to 0. Now, here I am taking all the negative to the positive side, basics. So V is equal to EB plus IA RA plus ISC into RSC. But in this second term, so this one, ISC is there now. ISC I am changing to IA. Why? Because those two currents are same. Okay. So I am modifying that. So therefore I can write V is equal to EB plus IA RA plus, I am changing this ISC. I am changing this ISC by IA. Okay, IA into RSC. Next what happens? See, next step, okay, I will be right here only. V is equal to EB plus, I am taking armature current common in both the terms. So then if I take IA common, then it become RA plus RSC, IA into RA plus RSC. So this is the voltage relation of DC series motor. For series motor, this is the voltage relation. V is equal to EB plus IA within bracket RA plus RSC. What is the other term? Brush drop. Very good. Okay. V brush drop. Okay. Or brush contact drop. Brush contact drop. If they given in the problem, then only add this term. If not given, don't take that term. Okay. Delete that term. Okay. Consider this brush contact drop 0. Okay. Got it? Okay guys, then later power input is V into IL. Power output is what? EB into IA. See, can I write EB into ISC? Yes, IA is equal to ISC. Can I write EB into IL? Very good. Yes, we can write because our currents are same. Okay guys, so pause the video and then copy down everything. Okay, while explaining, don't write anything. Now you can copy down. Okay, dear students, next is DC compound motor. See, compound motor is nothing but only one field winding, and we are separating that field winding. Part of the field winding we are connecting in series with the armature, and part of the field winding we are connecting across the armature. Okay, like that some arrangement will be there, but it is having both series and parallel combination. Okay. So we are arranging the field winding in both series as well as parallel. So coming to long shunt DC compound motor. In that, long shunt is one of the type in compound motor. Okay. See now, whether it is long shunt compound motor or short shunt compound motor. See, compound motor means always connect series field winding and armature winding. Okay. Both are always connected in series. Whether it is long shunt or short shunt, you should connect series field winding in series with the armature itself. Okay. Now across this series combination, if I connect winding, if I connect shunt field winding, then it is called. Now this is a diagram for long shunt DC compound motor. See, compound motor means always connect series field winding and armature winding in series. Across this series combination, you connect field winding, that is shunt field winding. Then it becomes long shunt. Then it becomes what? Long shunt compound generator. So definition is the shunt field winding is connected across the series combination of series field winding resistance and armature winding resistance. Okay, got it? So that is lengthy. You don't write definitions and all. Straight away, long shunt compound motor means directly you write this one. Okay. So now, see, this entire thing is motor. So motor is connected to supply. What happens? It's going to receive the line current. So that current comes till here. So after that, these two are connected in series. So obviously, these two will carry same current. What is current flowing here and what is current flowing here? See, this current will come till here. After that, some current flows in this side and some current flows in this side. Okay. So I am going to write the current flowing in shunt field winding is ISH. Why these currents are flowing? Because in parallel, the current will going to divide. Okay. The supply current divide in these two parallel branches. Okay. So now, what is the current flowing in series field winding? Very good. ISC. And what is the same current is flowing in the armature. Why? Because these two are connected in series. So the current flowing in armature is what? IA. So this is the diagram for long shunt DC compound motor. So now, so this I want to erase because it is same for this type of motor also. So now current relation. See, current relation. Apply KCL at this node. Before applying KCL, these two are same now. So I can write IA is equal to ISC. Both are same. Now apply KCL here. What is entering? IL. So line current is entering is equal to what is the currents outgoing? IA plus ISH. This current plus this current, or this current plus this current. Both are same. So IL is equal to IA plus ISH also you can write, or otherwise you can also write IL is equal to ISC plus ISH. Why? IA, ISC both are same, but I need armature current equation. So from this you write IA equation. From this one you write IA. What I can write IA? Very good. IL minus ISH. So IL minus ISH, that gives the armature current. Then how to find ISH? How to find ISH? Supply voltage by this resistance. This voltage by this resistance, you will get current in the shunt field winding. So V divided by RSH is current flowing in the shunt field winding. Similarly, V divided by RA, not IA. V divided by RSC, not ISC. Voltage divided by, this voltage minus back EMF divided by sum of these two resistance are connected in series. Add these two resistance. That current is IA current and also ISC current. Okay, fine. This is the current relations. Okay. Next is voltage relation. See, while replacing voltage relation, see, I am going to pause the video and then copy down this diagram because I am modifying here itself. Okay. Pause the video and then copy down. See, I am replacing just motor by its equivalent circuit. It is having armature resistance. Yes, RA, and it going to develop some voltage due to generating action in a motor. That voltage is called back EMF. Okay. So armature resistance. Now shunt field winding is there. Okay. Whenever shunt field winding is there, don't consider that for applying KVL. Okay. While writing voltage relation, shunt field winding is there na, you throw it to one side. Okay. Because the effect of ISH is already in the current relation. So therefore you should apply KVL to the outer loop. Okay. Apply KVL to the outer loop. Okay. Before applying KVL, mark the sign convention. Current enters plus, leaves minus. Enters plus, leaves minus. Okay. So minus to plus is rise. V. Plus to minus drop. Minus ISC, RSC. Plus to minus drop. Minus IA, RA. And plus to minus drop minus EV is equal to 0. Now basics. Okay, we can write from this. Next step will be like this: EB plus IA, RA plus ISC, RSE. Here I am changing again. ISC is equal to ISC equals IA. I will write. Okay. Now further, V is equal to EB plus IA, RA plus IA, RSE. I just changed this one, ISC to IA. Next, in this you take IA common factor. So V equals to EB plus IA within the bracket, RA plus RSE, RA plus RSE. So only this much is the voltage relation of long shunt compound DC motor. Along with this, you just add V brush contact to draw. So brush contact draw. Okay, brush contact draw. So if they give in the question, take it. Otherwise, neglect it. Okay. So they will give data like this: 1 volt per brush. So there will be 2 brushes. So this is the generalized representation. So minimum number of brushes will be 2. They will give 1 volt per brush. How many brushes? 2 brushes. So you write 2 volts. That's it. Okay, understood guys? This is the voltage relation. Now observe. Voltage relation of DC series motor and long shunt DC compound motor, both are same or different? Yes, 100% it is same. but 100% there is a difference. Okay, see, what is IA in this motor? Long shunt. What is IA? IL minus ISH. ISH is V by RSH. But in series motor, what is IA? Same as ISC and also same as IL. IA, ISC, IL all are same. So that's why it looks almost same, but there is 100% difference. Okay, got it? So that you need to identify. Okay, so don't buy at all this, because that's why I am teaching all the basics, how these equations are written, everything I explained. If you know this thing, even though if you forget also, you can apply KVL for a type of generator. So you can, generator or motor, you can get the voltage relations of either generator or motor. Okay. Okay guys, and the next is same this one, power input. What is input power to this motor? V into IL. And what is output power? Where the output power is produced? In the armature. EB into IA. And here also I can write EB into ISC, because IA, ISC same. So EB, IA is what? Gross mechanical power developed. Where this power going to be developed? In the, yes, very good, in the armature. So pause the video and then copy it up. Okay, dear students, last one, that is short shunt DC compound motor. See what I said? Compound motor means always write series field winding and armature resistance in series only. Those two are connected in series. Like that you write. Now, shunt field winding. You connect shunt field winding only across armature. Then it becomes short shunt. If I connect shunt field winding from here to here, then it becomes long shunt. So understood, no, the difference? See, now I am connecting the shunt field winding only across armature. Okay. So this is shunt field winding is having some resistance RSH. Okay. So now, see, now this entire motor is connected to the supply voltage. So once it get contact with supply voltage, this voltage source drive the current. That current, this entire motor going to receive the current. So what is the current coming from the line? IL or supply current or line current. Okay. So whatever the current coming from the line, same current is flowing to the series field winding. So therefore, what I can write current relation? What I can write current relation? IL is equal to, very good, IL is equal to ISC. Whatever the current coming from the line, same is flowing in the field winding, series field winding. So this current will be same till this point. Till that point, IL, ISC will be same. See, afterwards, what happened? Armature resistance and shunt field resistance. How these two are connected? Parallel or series? Very good, exactly correct. Yes, what you said, it is 100% correct. These two are connected in parallel. So this supply current divide in these two branches. So what is the current flowing in the armature? Armature current IA. What is the current flowing here? Exactly correct. Exactly what you said is correct. Yes, shunt field current. So that is denoted by ISH. Okay. Now you can write current relation. While writing voltage relation, what you need not to consider? Don't consider shunt field winding. Okay. Because if you consider shunt field winding, then this will be one loop and this is the outer loop. You should apply KVL for two loops. Lot of simplification. Finally, you will get same equation. So better I am considering all this in the current itself, current relation itself. So apply KCL at this node. What is the current entering? Entering current is IL. What are the currents outgoing? IA is outgoing, ISH is outgoing. IA plus ISH. IA plus ISH is the outgoing currents. Now you write equation for IA. Very simple. So many times we are writing this only. IA is equal to again what? IL minus ISH. Now very important is equation for ISH. What is the equation for ISH? Now don't say V by RSH. See, earlier it was connected here in long shunt. So it is connected to supply voltage by resistance current. Now it is connected here, not here. It is connected here. Okay. You must find voltage at this point. Voltage at this point divided by this resistance will give current in that winding. current in the shunt field winding. So how we get voltage at this point? See, there will be supply voltage and here drop will take place. This voltage minus drop in the series field winding. Some voltage is remaining. That is the voltage at this point. Okay. So therefore we can write supply voltage minus ILRSC divided by RSH. This is the equation for shunt field current. Okay, in short shunt compound motor. Okay, got it guys? Okay, otherwise or I can write this equation. Otherwise now come from this side. There will be back EMF and there will be IRA drop. Add this voltage and this voltage. Okay, adding this voltage plus this voltage will give voltage at this point. That voltage by resistance again shunt field current. So I will be writing that one. EB plus IARA divided by RSH. You can use any one equation while solving problems. But 99% of the problems asked on types of DC motors is this equation only. Okay, this equation is very important. So if you are using this equation means, then it indicates question is difficulty level increases. Okay, got it? So they will ask this only. Okay, till now they ask for this only. Very rare cases, 0.1% they can ask this one. Okay, fine. Now I will give the reason. V minus IL RSA. How can we write EB plus IARA after completing voltage relation? See, what is this voltage? Back EMF, IARA drop, add this voltage plus this voltage. Adding all this, what you will get? Supply voltage. So these are all the current relations for short shunt compound motor. Next is voltage relation. So guys, please pause the video and then copy down, because I am writing now voltage relation. For voltage relation, what should I make? I should replace the generator symbolic representation by what? Very good, equivalent circuit. So the generator symbol is represented and replaced by equivalent circuit. So plus and minus back EMF, and this will be RA, and the current flowing in the armature is IA. Okay. See, shunt field winding is there. Okay. Throw this winding at one side. Apply KVL without this winding. That's it. So then it becomes what? You are applying KVL for outer lobe. Okay. While applying KVL, what should we mark? Sign conventions. Current entering plus, leaves minus. Armature current is entering the resistance, plus and leaves minus. Apply KVL to the outer lobe. Okay. Applying KVL, we get V minus ISC RSE minus IARA minus EV equals to what? 0. Guys, important is ISC current and IA current. These two currents are not equal. Okay. See, if this is 100 ampere, 95 ampere flows here. Remaining 5 ampere is flowing this side. So then how can we tell IA and ISC are same? 95 and 100 are not equal. Okay. See, if this winding is not there, then this current and this current are same. But in the diagram, there is a current going to divert. Okay. What are the current coming from the series, in the series field winding? Same current is not flowing in the armature. Okay. Because part of this current is flowing in the field windings. Got it? Therefore, that's why don't take common factor IA. This drop is different. IRA drop is different. ISC RSC drop is different. Okay. That is the one important observation you should make it. Now V is equal to, take all this to right hand side. EB plus IARA plus ILRSE. See, ISC RSC I should write. If I take this right hand side, it become what? Plus ISC RSC. But I return ILRSC. Why means, what is ISC? Is is equal to what? IL. So that's why I written IL RC. Okay, got it? See, now this is the voltage relation of short shunt compound motor. See, EB plus IARA. Now you take this one left hand side, IL RC. Then what happens? Minus now. V minus IL RC can be written as what? Very good. EB plus IARA. That's why I written here. V minus IL RSA can also be written as what? EB plus IARA. So along with this you write V brush, okay, contact drop. So let me write correct word, BRUSH, brush. Okay, brush contact drop. See, if they given this data, consider. Otherwise, leave it. Take this one 0. Okay, got it? So I given a reason why V minus IL RSA, sorry, how V minus IL RSA can be written as EB plus IARA. Okay, got it? See, in the same equation, you can also write V minus, replace IL replace it and write ISC. Okay, got it? So that is also correct. V minus ISC RSC divided by RSH. That is also correct. So finally, what is the power input? What is power input? Very good. V into IL. What is the power developed or gross mechanical power developed in the armature? Or power output is what? EB into IA. EB into IA. So guys, by this we completed all the types of DC motors in your syllabus. Okay, for this particular subject code, whatever the portions are there, I covered everything in detail. See, the same concept we are applying on types of DC motors. So in the next lecture, I will be explaining characteristics of DC motor. Only one topic is left, a theoretical topic, that I will explain in the upcoming lecture. And later we should solve problems on motors. Okay, got it guys? So dear students and subscribers and viewers, if you are satisfied and happy with this lecture, please give like and share this lecture to all your engineering classmates who are studying in P cycle, already completed P cycle and currently studying P cycle students. Share it and tell them to subscribe. Okay, make your friends also so score good marks in this particular subject. So thank you very much. Have a nice day. Take care. Bye bye. Meet you on next lecture, characteristics of motors.